In this video, we're just going to do a brief overview of the different laws of exponents that we'll use when we simplify these different types of algebraic expressions. Now, hopefully you've seen some of these laws of exponents before, which is why you chose this video, because you're very comfortable with these rules and just want to get a brief refresher. The first thing that we have to keep in mind, we're going to ignore this adding and subtracting monomials part, we'll come back to that in our next unit, is when we're multiplying things that have the same base. When we multiply like bases, we add the exponents together. So x to the a times x to the b is x to the a plus b. For example, if we had x squared times x to the 7th, that answer would be x to the 9th. Similarly, if we have a power raised to another power, this is where we're going to multiply those exponents together. This is when we see one expression in parentheses being raised to another power. This is going to be x to the a times b. If we had x to the 2nd power raised to the 4th power, we multiply those together and we get x to the 8th power. Our quotient rule is the opposite of multiplication. So in multiplication, when we multiply like bases, we add the exponents. For division, we're going to subtract them. So x to the a divided by x to the b is going to give you a base of x, but now the difference of the exponents, always top minus bottom. If I had x to the 7th divided by x to the 3rd, we would subtract the exponents, and we end up with x to the 4th power. Anytime we have negative exponents, those represent the opposite of positive exponents. Positive exponents are a shortcut for repeated multiplication, and so negative exponents are a shortcut for repeated division. Whenever we want to simplify expressions, we're never going to leave a negative exponent out and about. We're always going to get rid of it by making it positive. In order to make a negative exponent positive, we take the expression and move it down into the denominator of a fraction. So if we pretend that this is x to the negative a over, not negative 1, over 1, then we turn this into a positive exponent by expressing that division. We move this whole thing, whatever the negative exponent is attached to, down into the denominator, and this is left with just a 1 in the numerator. This could also look something like if we had 1 over x to the negative a, we make this a positive exponent by bringing it up. So this would become x to the a. As soon as that exponent crosses over the fraction bar, its sign changes. So if we had x to the negative 4th power, this is the same thing as 1 divided by x to the 4th power, or you're dividing by x 4 times. The last thing we want to remember is that anything raised to the power of 0 is equal to 1. So if we had x to the 0, that's going to be equal to 1. If we have a number raised to the 0 power, that's equal to 1. If we had a whole long expression raised to the 0 power, that's also going to be equal to 1.